Yes guys, today we're going to be proving our addition formulae. So we start off by just drawing a triangle, right angle triangle with one of its angles x. That's all we need. Let's just drag this down because we need a bit more space. And then on top of it, sort of stacking on the triangle, if you want to see it like that. And we label this right angle triangle with an angle y. And we can label this 1, this length 1. Now from here we sort of want to like length chase, if you want to call it. So we'll label this sine y. Actually that's right, it's on the inside, you can see why they are. Sine y. And let's label this cos y. Now for this length here, obviously this is sine x multiplied by whatever this length here is, so that's sine x cos y, and then this is obviously cos x cos y. Now how does this actually bring about addition formulae? Well, we want what x on, well, sine and cos of x plus y. If we draw a line parallel to this length here, this angle here is x plus y. And we form another right angle triangle here. So since this is 1, our length here is sine x plus y, and then cos x plus y. So if we find this length here and this length here, we found our identities. So what we're missing? Well, for cos x plus y, if we find this length here, we can subtract that from the total base and we'll get it. Similarly for here, we just need to find this one length and we found it. So let's just form another right angle triangle. And oops, 90 degrees again, and we need an angle in here, so we can sort of angle chase. So we know this angle is x, so that is going to be 90 minus x. And then if this is 90 minus x, this angle plus that angle must add up to 90. So that's x, and that's all we need. So we've got the length sine y as our hypotenuse, so this length here is sine x sine y, and here we'd have cos x sine y. Voila, we've got our lengths that we needed. So sine x plus y, our height of our shape. So sine x plus y equals sine x cos y plus cos x sine y. So what we've just done there is just sum these two lengths. And now the second identity, so cos x plus y. So we start off by getting the base, cos x cos y, and then subtracting this length here, so sine x sine y. So now that's sort of the addition formula. Now what about a subtraction one? So when we have sine x minus y, so what we do here, so that's sine x minus y, we sort of let y equal to minus y. So then we have, let's just line that off. We have sine x cos of minus y plus cos x, and then we'd have sine of minus y. So sine x and cos of minus y, well, we just need to evaluate cos of minus y. So cos of minus y is the same as cos y. If I quickly draw you a cos graph, oops, minus y plus y, both the same. So cos minus y equals cos y. Now evaluate this bit here. So obviously cos x stays the same, sine minus y. Well, we know sine minus y to equal minus sine y. I can just show you that again. Oops. This point here and this point here, it's poorly drawn axis, but they're symmetrical. So if you take the minus of this, which is just the same as rotating it, we get this point here. So sine of minus y becomes minus sine y. So let's put that minus there and sine y there. And that's it. That's our subtraction formula for sine x minus y. And let's do the same for cos x plus y. So cos x minus y equals cos x cos minus y. Just fill that in. And then minus sine x sine minus y. So what we said before, that cos of minus y over here is the same as cos y. Cos x cos y minus sine x is the same. Sine of minus y is minus sine y. So that this minus here becomes a plus, so sine x sine y, and that's our subtraction formula for cos. Nice proof, wasn't too complicated. And yeah, now you know how to derive the addition and subtraction formulae. Goodbye.